Good morning, everybody. This is 419 Computable General Equilibrium Models, week 2. Today, we are going to start studying the positive properties of the Walrasian equilibrium. So, this is, I guess, chapter 1 of your book, or chapter 2, perhaps. I don't quite remember. I mean, after introduction, there's this chapter. Let me open my whiteboard. And okay. Now you will see my board. Okay. So again, the thing we are going to study today is Walrasian equilibrium. So this is the most fundamental definition of equilibrium. When we extend the model, the main properties of this equilibrium will be maintained. Okay, so this is highly central to what we are going to do in the rest of the semester. Okay. So we are going to imagine, of course, since this is a general equilibrium model, we are going to imagine more than one commodity. Okay. So I here is an index variable. So we have the first commodity, the second commodity, blah, 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 the nth commodity. All right. So each of these commodities will be priced in markets. All right. And also I should emphasize that this is an endowment economy. Endowment economy. So generally we have two types. First type, endowment economy. The second type, production economy. Okay. In the endowment economy, there is no production, which means the goods and services or the commodities are already there. They are like given to us, given to the consumers. Okay. This is sometimes called pure exchange. So the only thing that economic agents will do here is to exchange these commodities among each other. Okay. In the production economy, we're going to have two types of goods: primary goods or factors, production factors, also, and produced commodities. Okay, so some of these goods will be non-produced again, but they're going to be called production factors or inputs or primary factors, such as labor, land, capital stock, etc. And there will also be, again, produced goods. Okay, and produced goods will be sometimes called consumption goods and sometimes called intermediate inputs when they become inputs into other firms' production processes. Okay, so what we study here is the simple endowment economy, again, sometimes called pure exchange. All right, so we have n different commodities in this economy. Then we have households. Again, we have more than one household. Okay, there are many people in this economy. And when I say household, you may imagine a family, or you can imagine a single person as well. At this level of abstraction, this is not a big deal. Okay. Now, we're gonna have what we call a price vector. Okay. So this will be a price vector, and we are going to usually be interested in strictly positive prices, okay? Because if the price of a good is equal to 0, let's say for some PI, then I is free good, right? I is free. Since it is free, it is not a big concern to us. You can go and consume it. So for this reason, usually we are going to be interested in strictly positive prices. So what does this mean? So this is n-dimensional Euclidean space. Okay, why n-dimensional? Because we have one price, two price, n prices. All right. So this is called, of course, the price vector then. All right. Now, an important concept here is endowment, of course. Okay. Now, this denotes household H's endowment of commodity I. Okay. As I said, here commodities are given to people, given to households. So I have, let's say, 2 computers, 1 cell phone, 4 chairs, 17 t-shirts, and 1 refrigerator. And then for some of the commodities in the economy, I may have no endowment as well. Okay? So all of the commodities are basically distributed across people. So this is then the household H's, okay, endowment of commodity I. All right? And of course, this defines an endowment vector for, this defines an endowment vector for household H. Right? And this endowment vector will be again n-dimensional, but it could be non-negative. All right? So difference between, let me emphasize with color. Difference between 2 pluses and 1 plus here is that here in the price vector, all the prices are strictly positive. Okay? So here, all the prices are strictly positive. Now, do you know what symbol is this? This means for all. Okay, the reverse A means for all. Okay, so with 2 positive dots, this is the positive orthant. We have all prices strictly positive. Here, we have EIH equals 0 for some I. Okay? That's the difference, because some people will not have, may not have all the goods. All right? So any questions so far? Okay. So let me export this one very quickly. And start with a new one. All right. So we have people. Okay. So we have commodities indexed by I. We have people indexed by H. Okay. Now, we also have the endowments. Okay. So if you think about this in a matrix. So you have a rectangular array of numbers, right? Some of them are 0. So this is like a matrix, right? Oops. Okay. So E11, E12, dot, 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 E1H, E21, E22, E2H, right? This goes on like this. At the end, we have ENH. All right? So now forget about the math and the notation and other stuff, and think about it in this way. What's gonna, what are the, what's the economic action here in this economy? So, okay, we are there, H people, and we all have some commodities. All right? So what are we gonna do? Of course, you must think that some of these commodities I own as a single consumer or household, I may not prefer them to some others, right? And there are other people in the economy who have some of the commodities that do not prefer, or that do not prefer that much, all right? So in a large economy like this, with too many consumers and too many commodities, every single person endowed, one thing they can do is exchange, obviously, right? Because if they have different preferences, if they value these commodities differently, then there is some room for welfare increase, right? This is the entire idea of economic exchange. I have something, and my opponent has something else. I prefer to have that something else that he or she owns, and if he or she also prefers what I have, and which I don't really prefer that much, then there is a room for exchange, and through this exchange, we can increase our welfare, we can increase our utility. So that's the entire idea, of course, and we're gonna do basically that. But for this to happen, of course, I need to have income, right? But here, the entire source of income is my endowment, because there is no work in this economy. There is no firm, there's no production, there's no profit, there's no wage. So if I want to go into exchange, I have to, supply something as well, and that supply will be my endowment, obviously. So if you want to write total income of a person, you can do something like this, right? So price is P1 for the first commodity, and I have E1H. All right? Right? So if I sell this first commodity of mine in a market, then that market will have price P1. That's our notation. Then the entire income I could obtain by selling my first commodity is this. Plus, I can also sell my endowment of the second commodity, right? Now, this is household H. I am writing this for household H, right? Then there is P3, E3H, dot, dot, dot. And then finally, I have PN, ENH. Okay? So this becomes total income of household H. Okay? Now, remember our consumer theory. So I'm talking about prices, okay? I'm talking about income. Now, how do I use these inputs to define what? I usually define these inputs to define what we call demand, right? Sorry, This is something going. All right. Okay. So this is chi. Okay. Maybe I can do better. So this is a Greek letter chi, and we are going to use chi as a demand function. So what does it tell you? It tells you that demand function for commodity I by household H. Okay? So this tells you that household H's demand for commodity I depends on the entire price vector. Okay, because these commodities could be complements and substitutes, for instance. Okay, and also it depends on the endowment vector of the household H. Okay, so if I go to the market, I will basically tell my opponents, my fellow exchangers, that okay, I will have a demand function for this. So if the prices are this, you observe price. If prices are P1, P2, Pn, and I know my endowment, so I know my income, right? If I know prices, I already know my endowments. Okay, so I can define my demand for each commodity. Now, of course, usually we derive this from utility maximization, right? In this lecture, we're going to pass through that. In this lecture, for illustrative purposes, we are working directly with the demand function. Okay, and this demand function has some properties. Most important is that, I mean, there's of course continuity assumptions as well, and other stuff. But an important assumption is if you increase prices, if you increase all prices by the same amount, by the same factor, same proportion, let's say all prices double, or all prices cut 1/2, okay? Then nothing changes in terms of demand, right? There is no money illusion or other complicated things going on here. It is about the homogeneity of this function, all right? So if you, for instance, go look at the Cobb-Douglas model, so if you assume a utility function, which is Cobb-Douglas, and if you solve the standard utility maximization problem for consumption theory, then you will find such homogeneous demand functions. All right. In that case, if all prices double, so as long as all prices change, I mean, the idea is that your income also changes. So, okay, that's the idea. If prices double, your income doubles. Okay, so there's no change in real terms. All right. Now, let me also export this one. Okay. Maybe I can go like this. All right. Anyway, I can do it later on. So, another important concept we are going to define is excess demand. Okay, so this is excess demand function for commodity I. Okay. Now, what is an excess demand function? Excess demand function is basically total demand minus total supply, right? This is excess demand. And of course, it depends on prices. Okay? It depends on prices. Now, at the end, we're going to arrive this excess demand function, and it will be very important when we discuss the existence, uniqueness, and stability of the equilibrium. Okay. Now, for some time, we're gonna leave it there, and we're gonna return back to it. All right. Now, let's think about the budget constraint. I already written the income, right? So income of household H was like this. So income was like P1, P1H, right? Income of H, let's say, plus P2, P2H, dot, 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 P, N, E, N, H, all right? And what about the expenditure? Expenditure is like this, right? I'm paying P1 for commodity 1. So I have X1H, PEH, plus for the second commodity, I am paying X2H, PEH, dot, dot, dot. For the nth commodity, I am paying this. All right? So we can also write this in this way, right? For household H, I have PI, XIH, PEH. So let me do a better job here. Okay, let me do a better job here. All right. So this is expenditure, and income is, be careful, I am summing over commodities, right? So this is for household H. So what this is? So this is a budget constraint. Of household H. Okay? Now, the idea is this. If everyone in this economy spend all their income, all right? If everyone in this economy spend all their income, so in that sense, they're, let's say, rational, okay, because consuming more is better, right? Standard neoclassical assumptions. Then we can prove something very important. We can prove what we call Walras law, okay? So we are going to use this to prove Walras law, okay? Now, how much time I have? Let me check. Okay, I still have 6 minutes, around 6, so I can continue. So basically, we're gonna start with that particular property. Now I'm going to write in this way, okay? This means I am summing over commodities, okay? And this means I'm summing over households. Okay. Now, I have for household H, PI, PEH, right? And I assume household uses all the income. Now, as you see, I can simply do this, right? Let me double check my notation. Yeah, I can do this. I can sum these terms. I can sum these terms by households. Okay. So I am trying to find, oops. I'm trying to find the market demand and market supply. Okay. So key IH PEH must be equal to, okay, no, I have a mistake here. Okay. Okay. Basically, I'm summing over households to find the total expenditure and total income. Okay. Now, one thing is important here. Okay. So how do you proceed? What's the next step? You must see it. You must be seeing it. Now, as you see here, for instance, just look at here. So here, oops, sorry. So EH. So basically, this term depends on household level, right? So the household index is here, and same is true for this term, right? So I can actually write in this way. I can basically switch these summations appropriately, okay? So I can, in principle, have this. Okay? Because price, I mean, PI is common multiplier for each age, right? So sorry, this will be endowment EI. Okay, let me double check whether I am doing it correct. Yes. So if you think this is like magic, it is not magic. So you can just write explicitly. All right. So it is gonna end right now, and I will continue. Let's say at 10 a.m. All right. 10 a.m. I'm gonna meet with you after 10-minute break. Okay.
Tamam hocam.
Okay. Bye bye.